This is a thin plastic film made from recycled polyethylene. Films like this find wide application in packaging, agriculture, and construction. However, impurities in the recyclate can drastically alter the mechanical and chemical properties of such films. DIN Spec 91446 explicitly mentions FTIR as the go-to method to characterize the quality of recycled plastics. Looking at our sample, we can already make out some dark spots in the plastic film. In this video, FTIR imaging will help us take a closer look and identify the impurities. First, we have to fix the film in a special sample holder for films and filters. Then we clip it into the validation plate and place it in the Lumos 2. In the visual image, we can see that the sample is far from homogeneous, as expected for a film made from recyclate. We collect an overview image for reference and select the focal plane array imaging detector. Combined with a transmission measurement, it will allow us to rapidly characterize the impurities within the PE matrix. Using a predefined background is key to receive spectra of good quality. Now we select a region of interest. Each red tile will collect 1024 IR spectra. Lastly, we give the sample a name and click Start Measurement. After a few minutes, the Lumos 2 has mapped the region of interest. By using Bruker's adaptive chemical imaging, we analyze the sample with a single click. The machine learning algorithm has identified several foreign substances: polyethylene terephthalate, or PET, polyamide, or PA, cellulose, and a few more. This approach can also be applied to bulk measurements using an FTIR spectrometer like the Alpha 2. Check the description if you want to know more. Thank you for watching.